the capacity is scales with the area that you have and is divided by the distance. And both of these parameters are absolutely extreme here. So what you use as a material is called activated carbon. It has a huge surface area. So in like a piece of my hand, you have several thousand square meters of surface because it just goes on a microscopic level up and down and up and down and so on. And the distance of the charge carriers is really, really small. It's in a couple of nanometers. So this is maximized. That's why they have really high energy density compared to, I don't know, your ACOs or any form of caps you can put on a PCB. But their energy density is still really small compared to batteries. Lead acid battery or lithium battery. This is the small energy density. You also find that one electrode is a lithium battery and the other electrode is a capacitor. This is, you can buy it actually on the market. It exists. It's called lithium capacitor or hybrid capacitor. It exists and it combines, the energy is higher, of course, and you still have very fast charge and discharge times, but I have never seen a major application. I'm wondering if this will ever really be on the market or not. Yes, as I said, I think strength is clear, very high efficiency because there's no chemical process involved, around 99%, round trip and 90 to 94%, and really high cycle life. So when you talk with lithium batteries, 2,000–3,000 cycles, here you talk about millions of cycles that you can do. Typical applications, also frequency control, but peak shaving, everything. For example, if you are a company, let's say you are an aluminum production company and you need to melt your aluminum to have liquid aluminum to produce something, the initial step of melting to heat everything up that requires so much power. So the peak power is really high, but once it's molten in liquid, you don't need so much power. And that's where you could include, for example, the supercap energy storage. That's what peak shaving is, to shave the power peak off. And the trick is you pay much less electricity costs because usually you pay always for the maximum peak power that is provided to your site and not for the mean power. So peak shaving actually saves a lot of money. It's a typical application for supercaps. And one really typical application is, because they have such a long lifetime and high power, is in wind turbines. As a safety mechanism, when something goes wrong, they spin too fast, or I don't know, the inverter doesn't work, or the generator, the blades, you can, as a, let's say, emergency power off, you can spin them out of the wind. So you can, if it's like this and the wind is coming, you can just spin them like this, and they almost get no more wind, and so it stops spinning. And to make this move, anytime, anywhere, without power supply, you use supercaps. This is one of the main use cases of supercaps, for example. A little bit more complicated, but also high number. So, okay.
Using aerators.
Yeah.
So the technique that we use in aerators to give the direction change, we use that
I think not, no. I think this is done with hydraulics instead, and also emergency operation. I think there are no supercaps or anything involved. I think, I'm not sure. Yes, this is where hydraulic system, once you have the movement done, you don't require more energy to keep it. Yeah. So in planes, this one of the major, I think, electrification efforts for planes is to remove the hydraulics. So instead of that you have the wing movement with hydraulic lines, that you have it with a small motor and a battery. This is, for example, one effort to electrification for airplanes. But I think 99% or almost everything is still hydraulics, to my knowledge. So, that's the brief words. Yeah, hydrogen we talk a lot about, it's very important, but it can also act as a storage, and in some words as hydrogen as a storage solution. Yeah. So what you do is, you see here, renewable power source. You have too much energy, you don't know what to do with it. You throw on your electrolyzer and you produce hydrogen. Yeah. And this hydrogen you store somewhere, and there are also several ways to store it. High pressure, lower pressure, very cold, room temperature, and so on. There are many different ideas, but it works. And the good thing is hydrogen has very high energy density. So that is the one big advantage. And you can use it for many, many useful applications. So you can use underground storage, also has a small footprint. And what you use as a primary resource to produce the hydrogen is just water. So that is one technology that is really not restricted by the resources or materials it uses, because water is the #1 most available resource on the planet. Not drinking water, you can use seawater or anything that is not drinkable. So it's one very big advantage. And of course it's really expensive at the moment. And as I said, yes, there's a lot of discussion, but the only economically realistic option at the moment is to have it as a medium to long-term storage solution. To put the energy in hydrogen and store it for months, 2 years. Okay, then one step further, power to gas. This is the same, let's say the same idea like this one, but applied more generally, that you do not only produce hydrogen, but in theory, you can also take the hydrogen and do something else with it that is more beneficial. And as I said, one of the main topics that is in development is to produce methane, CH4. So it has higher energy density and is less volatile. So the molecule itself is larger, meaning it's easier to store and to transport. So what happens is very similar. Yes, so you have a renewable source, you have electrolysis done, then you move to methanation. And this methane you can then use again as storage. You can directly consume it in your chemical or pharmaceutical industry, or you can make electricity out of it. So as I said, it's the same idea, but using methane. This is in the afternoon then, has quite some advantages over hydrogen. So, there's a technology for long-term storage. This section is about storage, yes. So, methane would be very nice as a storage gas and to use it later. Problem is very low efficiency. There are many, many process steps involved. You need CO2 externally from it, and to get this CO2 is actually really complicated, unfortunately. But in theory, you could take advantage of the very large energy density, very high energy density of this. So it's even much larger than hydrogen energy density. Yeah. Any questions? More or less clear. So these were, let's say, select technologies just to show what is available in theory. And I think it's clear you can think of many things, but currently batteries are the #1 trend and probably will remain so in the next decades. Unfortunately, it's not all engineering. Just to show you have really many parameters you need to consider when you let's say you're standing there and say, I need an energy storage. What do you need to consider? If you buy it yourself, first thing you consider is how expensive is it? That's clear. Companies do the same. Yeah, and yeah, as I see, lifetime is important, but how expensive is the installation cost or invest cost to get it running? What is maintenance? For how much money can I sell my electricity? Or do I use electricity and do I need to buy electricity and so on? This is everything that's important when you design it. For tomorrow I have a small exercise where you can calculate a little bit. And you see sometimes it takes a very long time to get back your investment, and for some application it goes very fast. So this is one huge driver for what technology you want to use. This is something very complicated. There's a lot of info that you can take a look yourself later on. This is a graph that shows also remote clock, basically. So here on the x-axis you see how much energy the system has, and this is not density but real energy. So you see here H2, typical H2 storages are installed from 10 megawatt hours to 100 gigawatt hours, and not some form of density. And at what power these plants usually operate. So when you look at the double layer capacitor power plant, usually the ones that are in operation, they operate from 100 kilowatt to 1 megawatt and have like 0.1 kilowatt hours installed. And so it's quite interesting to look at. This is the flywheel electrical storage. You see has quite a broad window that is possible. So here compressed air storage, pumped hydrogen, and pumped hydro. Sorry. If you just want to look up where to find this and that technology, that's a very nice picture. So I have two slides as a very fast summary. What we want to do, I like the word, what we want to do with energy storages is actually we want to shift energy both spatially, so we want to move energy from one location to the other location, and we want to shift it in time. So we don't want to use it now but later. So what is required? Flexibility, technologies for spatial and temporal shifting of energy. Yeah, so it's important that you need to do demand side management in energy, and in the private households you need to consider if you can maybe use your storage for several applications, like your car battery, to use it as a storage for your home and so on. Power to gas will gain importance and is quite important, especially to not hydrogen but to something else like methane. We talk about, of course, that we need to extend the electrical grid. I think that's clear, transmission lines as well as distribution grids. Power to heat via heat pumps is I think, gaining application. Energy storage systems is mostly focused around current electrochemical storages, so that is batteries, lithium batteries. We need to have smart grids ideally, because what we don't want to have is we don't want to shut down our renewable energy sources when they're producing too much energy. We want to store it. So we have many technologies available. Almost all of them are in use or are important. So redox flow batteries, hydrogen, pumped hydro, power plants, superconducting coils. We have batteries in vehicles. We have batteries in homes and apartment buildings, flywheels, batteries, parkettes, and so on and so on. So that was my last slide for this section. If you have any questions, please. Otherwise, I think we make a short break and then we can do some more stuff.
Hydrogen motors.
Yeah.
With the lithium-ion batteries, one of the major issue with them is the availability of lithium.
हायड्रोजनला खूप प्युअर पाणी पाहिजे लागतं ना, मी तेच विचारणार आहे.
But is it possible to
त्याला सी वॉटरनी चालणार,
possible to
सॉल्टेड वॉटरनी
recycle
चालणार त्याला.
most of
तसं नाही आहे.
it.
दोन टाईपचं हायड्रोजन जनरेशन आहे. एक गटर आणि ड्रेनेज पाण्यानं मिथेन आणि बुटेन अलग करून हायड्रोजन बनवणे आणि पाण्यात इलेक्ट्रोलिसिस प्रोसेस करून हायड्रोजन बनवणे. आम्ही ती प्रोसेस बघितली होती.
ते वर्कशॉप होता तिथे
त्या वॉटर
ते आलं होतं
काय होतं रे त्या
One day
वॉटरचं नाव?
Yes. In theory possible, practical application making new is
लिहिलंय ना,
much more.
DM वॉटर लागतं, DM वॉटर, DY वॉटर.
There's research ongoing.
PKCच आहे. DM वॉटर, DY वॉटर, TDS वॉटर, सिमेंट्स पर सेकंड, 4 सिमेंट्सची आत पाहिजे का कंडक्टिव्हिटी.
प्युअर वॉटर पाहिजे थोडंफार.
Yes.
ड्रिंकेबल वॉटर पाणी पिण्यायोग्य पाणी आहे.
नाही ते गेले नाही अजून हायड्रोजनवर. मी विचारणार आहोत, नाही काय विचारणार आहोत मी काय सोडणार आहोत पर्सनली नाही, आत्ताच विचारणार असेल. बाकी त्याला जाऊ दे.
So this
हां,
is in Europe.
पण त्याला बी वेळ नाही भेटणार आहे. तो चहा पिईन, तो चहा पिता पिता मग त्याला विचारायला लागेल.
Regulation
सेशन क्लोज होणार का?
in the next years there's
नाही रे,
you are forced to
आता हायड्रोजन
recycle
सांगणार
materials for the battery and that you keep track of the resources.
नाही, तो लिथियम आयनवर सांगत आहे. तो म्हणत आहे हायड्रोजन चालू करायच्या आधी लिथियम आयनवर विचारून घेणार.
With the waste management, yes, because that is an issue absolutely.
मला तर बॅटरी प्रकार आवडतच नाही. बॅटरी मला आवडतच नाही.
China, for example, by far the biggest manufacturer, they don't care so much because they just have
त्यापेक्षा मला हायड्रोजन आवडते.
everything
हायड्रोजन स्टोरेज
in their own
आवडते.
country. So I think it's a little bit different in Europe.
हॅझर्डियस मटेरियल कसं रिसायकल करणार तू?
Countries maybe not so. Yes.
हायड्रोजन आवडतच नाही आहे, पण थोडं हे आहे कॉस्टली.
हाय पॉवर सर, which category of battery can give us high power density as well as high energy density?
Not one, I would say. So to have everything optimized, you don't find it. Usually you use, depending on how many battery cells you need, the company that produces will make a battery cell only for you. You say, I need this power and this energy, and they will produce it for you if you buy 500 million, for example. But otherwise you can buy different things. So usually you buy high power or high energy density battery. Both at the same time, not available. Okay. Yeah.
माझ्या मते कोणता पण पाणी यूज करू शकतो, तर त्याला तो DM करावा, डिमिनरलाइज. मग फिल्ट्रेशन कॉस्ट आली, फिल्ट्रेशन प्लांट आला. एक आहे कोणीतरी सांगितलं सॉल्ट वॉटर पण वापरून करा लागले प्रोसेस असं म्हणलं.
Still the problem to use just
ती एक
new
मेथड झाली
batteries for
सॉल्ट
everything you
सॉल्ट
want to
वॉटरला
produce.
यूज करून.
But there are many research projects ongoing to take on more
पण tap water पण चालते.
stationary storage.
वापरलं जाते.
डिमिनरलाइज करणं.
Investigations are ongoing, but nothing
सॉल्ट वॉटरमध्ये
industrial use.
हे टाकून करतात, जे सर्फ एक्सेलमध्ये जो केमिकल आहे ना, सर्फ एक्सेल म्हणा, जे वॉटरला मोर कंडक्टिव्ह बनवते सॉल्टसोबत, ते एक वापरून इलेक्ट्रोलिसिस प्रोसेस करतात. प्रोसेसेस चेंज होते. प्रोसेसेस चेंज होते.
So, to my knowledge, it is not
सॉल्ट
necessary to
वॉटरमध्ये त्या NaC आले.
higher
त्या NaC सोबत तुला
because, I mean,
तुला
the way you
त्याला हँडल करावं
use batteries, they last 15 to 20 years.
कॉस्टली आहे.
कॉस्टली
एक्स्ट्रॅक्शन कॉस्टली आहे.
म्हणजे मी वाचलं जे शॅम्पूमध्ये कंटेंट राहतात त्यातला तो एक कंटेंट वापरतात त्याच्यात. आणि सॉल्ट वॉटर जर असेल तर त्यासोबत जे आपले सर्फ एक्सेल निर्मामध्ये जो कंटेंट आहे तो कंटेंट वापरतात.
New technology that is dramatically better in lifetime. That's what it is.
बेस्ट सबसे
It's good
बेस्ट
enough already.
भाई तो यही हो गया है, सर के पास जाना पड़ेगा अभी. सर के